In this video, we will add and subtract rational expressions. We're going to start off by just reminding ourselves how we add and subtract numerical fractions. We always need common denominators to add fractions. So if I look at this problem at the top, I need a least common denominator. So between 3 and 4, I need to find their least common multiple. The least common multiple of 3 and 4 is 12. So I need to make my denominators 12s. And to the first fraction, I'm going to do that by multiplying by 4 over 4. And in the second one, I'm going to multiply by 3 over 3. And I have to multiply by something over itself because then I'm really just multiplying by 1. So I end up with top times top, 8 over 12, bottom times bottom, plus 9 over 12. And now that my denominators match, I can add the tops together, and we get 17 over 12. And you can leave answers in improper fraction form. So we're going to do that same thing with expressions. In number 1, I already have common denominators, so all I have to do is add the numerators together, and combine it into one fraction. So I'm going to add 2x squared minus 4 plus x plus 3 all into one fraction over that common denominator 2x plus 5. And now I'm going to simplify by combining like terms, and I always want to leave my answer in factored form just to make sure that I've simplified as much as I can. So combining like terms, I can combine the minus 4 and the plus 3, and I get 2x squared plus x minus 1 over 2x plus 5. And now I want to try and factor that just to see if it can be factored. So I'm going to go to 2 sets of parentheses. 2x and x would give me 2x squared. It would have to be 1 and 1 to give me a 1. And that's 1x and 2x. If one of those is positive and one is negative, that should work. I want my 2x to be positive and my 1x negative. So if I put a minus here and a plus here, I believe that works. So I'll rewrite the bottom. And I check to see, I can't factor out a common factor or anything in the bottom. So I always check to see if any factors cancel and if it can be simplified. And in this case it can't, so that's my final answer. And your final answer is really fine in either of these forms, but the benefit of factored form is you can check to make sure that the expression can't be simplified anymore. Okay, in the next one, again, we already have common denominators, but this time we have subtraction, and we have to be careful to distribute the negative when I subtract that expression 3x plus 2. So I'm going to get x minus parentheses 3x plus 2 when I combine it into one fraction over x minus 3. And I distribute my negative and get x minus 3x minus 2 over x minus 3. And then combine like terms on the top, and we get negative 2x minus 2 over x minus 3. I can factor out a GCF in the top. I can factor out a negative 2. And so I will get negative 2 times the quantity x plus 1 over x minus 3. But again, I don't have any factors that will cancel out, so that's as far as we can go. Now, in this third example, we almost have common denominators, but not quite. We have an x minus 1 in one, and then in the other, 1 minus x. But if we factor out a negative in that second fraction in the bottom, we can get those to match. So if I take 1 minus x, and I factor a negative out. I'm going to put a negative out front, and my 1 would change to -1, and my x is going to change to positive x. And if I switch around their order, that would be x minus 1 with a negative out front. So I can rewrite this as 2x over x minus 1, and then that minus is going to make this a subtraction problem. So I'm going to put that minus out front of that fraction instead of that plus, and on the bottom, x minus 1. And now that I have common denominators, I combine these into one fraction. On the top we have 2x minus 5, on the bottom x minus 1. And I don't think we can factor, so that would be our final answer. In these next examples, we're going to have to do a little more work to get common denominators. So when you find common denominators, you're finding the least common multiple of the expressions in the denominators. So the least common multiple of 10x and 5x squared is going to be the product of the factors raised to the greatest power that occurs. So if we think about 10 and 5, their least common multiple is 10. And then we have an x and an x squared. We need the greatest power that occurs, so x squared is going to be needed. So we want both of these fractions to have 10x squared for the denominator. And I look at each fraction and decide what it needs. So in this first one, I'm going to multiply it's missing the x squared, so it needs an x. So I'm going to multiply the first one by x over x. And in the second one, it's missing, it needs a 10 for its coefficient. It has a 5, so it needs to be multiplied by 2 over 2 to give us 10x squared. And so now I do that, and when I multiply the first one, x times -4 is -4x on top. On the bottom, we get 10x squared. In the second fraction, 6 times 2 is 12, and 5x squared times 2 is 10x squared. And now we have common denominators. We can add these together. So -4x plus 12, we just combine those. They're not like terms, so we write them in one expression, in one fraction, over 10x squared. And then we always want to fully factor, combine like terms if you can, and then you fully factor the expression to see if anything can cancel out. So on the top, we do have a GCF. I could factor out -4 or 4. I'm going to factor out -4 because it's always a good idea to factor out a negative if your leading term is negative. And we would get x minus 3. And on the bottom, we have 10x squared still. And I can simplify the 4 with the 10. They can both be divided by 2. So if I divide them both by 2, that becomes a -2. And this becomes a 5. So our final answer is going to be -2 times the quantity x minus 3 over 5x squared. In the next one, the least common multiple is going to look a little different. X plus 4 and x minus 2 are two different factors. So our least common multiple is going to need to include both x plus 4 and x minus 2. So our first fraction is missing the x minus 2 part. So I'm going to multiply it by x minus 2 over x minus 2. And I'm going to put that in parentheses because when I multiply on the top, I'm going to have to multiply two binomials or distribute or FOIL, whatever you call it. And in our second fraction, we're missing the x plus 4 part. So we're going to multiply by x plus 4 over x plus 4. And everything really needs parentheses. And now I can combine this into one fraction. So I'm going to get x minus 2 times x minus 3 plus x times x plus 4, all in one fraction. And then on the bottom, we're going to have x minus 2 times x plus 4. The bottom is already in factored form, so I'm going to leave it alone. On the top, we might be tempted to cancel stuff on the top with stuff on the bottom, but the top is not truly in factored form until we distribute, combine like terms, and then factor again. So that is the most common mistake I see with these, is people start canceling stuff right now, but we cannot cancel stuff yet. We are going to have to distribute, FOIL right here, and distribute here, and combine like terms, and then once we've simplified, then we can factor. So if I distribute in those first two binomials, I get x squared minus 3x minus 2x plus 6, and then distribute the x times the x plus 4, I get plus x squared plus 4x, and on the bottom, I'm just going to leave x minus 2 times x plus 4. And now I have quite a few like terms that I can combine. My x squareds can go together, my negative 3x, negative 2x, and positive 4x can go together. So we get 2x squared, and minus 3x minus 2x is negative 5x, plus 4x would be negative 1x, and then plus 6 over x minus 2, x plus 4. And now that I've completely simplified the top, now I check to see if that can be factored. So I'm going to try and factor the expression on top. I'm going to start with a 2x and an x to multiply to 2x squared. And then I need to think of factors of 6. That might work. And I think I'm going to try 2 and 3. And I'm going to put the 3 here and the 2 here. And let's see if that works. So if I do minus minus, which I need to add to a negative but multiply to a positive, that's not going to work because I've got negative 3x and negative 4x, and that doesn't work. So I try something else, like maybe 6 and 1, and let's see if that works. So if I put maybe a 6, whoa, that's not what I wanted. A 6 here and a 1 here, I get negative 6x and negative 2x, and that's still not going to work. So I think I'm out of luck, and this just isn't going to be factorable, because even if I switch those around, that's still not going to work. So that tells me that this is as far as I could go, and that's my simplified answer. At this point, if you feel confident enough to pause the video and try these yourself, I think that's a great idea. If not, I will go through them in case you'd like to listen. Okay, so the next one, we want to get the bottom fully factored. So x squared minus 4 can be x plus 2, x minus 2. And so the factors that I have in the bottom are going to include x plus 2, x minus 2, and x. That's going to be my least common multiple. It's going to need all of those factors. Okay, so I'm going to rewrite this. X squared over x plus 2, x minus 2, minus 1 over x. Now my first fraction needs to be multiplied by x over x to get the x in the bottom. So I'm going to multiply by x over x. And my second fraction is missing the x plus 2 and the x minus 2. So I'm going to multiply by both of those over themselves. And that should give me common denominators. So in the first one, when I multiply the tops, I get x to the third power over x times x plus 2, x minus 2. And I can go ahead and combine these into one fraction because I do have common denominators now. So then I'm going to have minus, and it's 1 times x plus 2 times x minus 2 on the top. So that's really just minus x plus 2 times x minus 2. And now I can't cancel stuff yet. Don't be tempted to. It's not in factored form until it's all a bunch of factors being multiplied together. So what we have to do instead is distribute, combine like terms, and then see if we can factor. So I need to distribute, I need to FOIL right here, and then combine like terms. So on the top, we're going to get x cubed minus, and I'm going to keep my parentheses when I FOIL, because that negative is going to have to get distributed. So I get x squared, and then I have minus 2x plus 2x, and minus 4. And my middle terms are going to cancel out. And I keep my denominator the same. Now, I'm going to have to distribute that negative to the x squared and to my negative 4. So I end up with x to the third minus x squared plus 4 over x times x plus 2, x minus 2. And I can't factor the top, so because there's no GCF, I can't do two binomials, so that's as far as I can go. This video is getting long. This is a lot of examples, so feel free to turn this off if you've seen enough, but I will keep going in case you'd like to continue. So in this one, first I want to factor the bottoms so I can identify what factors we have. So I'm going to rewrite these in factored form, and we get x and 2 and 1, and if we add them both, that should work. In the next one, we have a difference of squares, x minus 1 and x plus 1. So for our least common multiple, they already have x plus 1 in common. They both have that, so that's going to be part of the least common multiple. The one on the left has an x plus 2, and the one on the right has an x minus 1. So all three of those factors need to be in the least common multiple. So our first fraction is going to be multiplied by what it's missing, which is the x minus 1 over itself. And the second one is missing the x plus 2. So I'm going to multiply by x plus 2 over x plus 2. And I'm going to combine these all into one fraction. So we end up with x minus 1 times x plus 2x minus 3, notice I put parentheses around that, times x plus 2 over x minus 1 times x plus 2 times x plus 1. Now, can I just cancel stuff like the x plus 2's? No, I cannot, because the top is not in factored form. I have to distribute, combine like terms, and then I can try to factor it. So I need to distribute here, I need to FOIL here, and combine like terms first. So we end up with x squared minus x plus, now this time, since I have addition, I don't have to be so careful about keeping brackets around the part that I FOIL, because I'm just going to be adding everything. So we get 2x times x is 2x squared plus 4x minus 3x minus 6. And I keep my denominator the same. And then I combine like terms in my numerator. So x squared can be added to 2x squared, and negative x, 4x, and negative 3x can be combined. So we get 3x squared, and then negative x plus 4x minus 3x ends up canceling out. So we just get 3x squared minus 6 over all that fun stuff. And we check to see if we can factor. I can factor out a 3 on the top. And that's as far as I can go. So that's my final answer. And then our last one more example, if you're still with me. Again, I write it in factored form. On the bottom of that first fraction, I can factor out an x, so I get x times x plus 1. And in the next one, I can factor, we get x plus 1 times x plus 1. So I have the same, that second one has x plus 1 twice, or x plus 1 to the second power is another way to write that. So in my least common multiple, I am going to need x plus 1 twice. And I'm also going to need the x that shows up in the first one. Another way to write that would be x plus 1 squared times x. Okay, so the first fraction needs another x plus 1 over it, so I multiply by that over itself. The second fraction needs the x, so I multiply by x over x. And on the left-hand side, x plus 1 times 3 is on the top, minus, I'm combining them into one fraction. I'm going to put x plus 4 in parentheses, and then it's being multiplied by x. And on the bottom, I'm going to have all that stuff, an x and an x plus 1 to the second power. Now I simplify on the top, so I'm going to distribute, and I get 3x plus 3. Now I haven't distributed my negative yet, so I'm just distributing the x, and I get x squared plus 4x. And now I'm going to distribute that negative to both of those terms. And we get 3x plus 3 minus x squared minus 4x all over x times x plus 1 squared. And I combine like terms. I'm going to write negative x squared first, minus x minus plus 3 over x times x plus 1 squared. And I check to see if I can factor. I can factor out a negative from that expression on the top. So I'll get negative x squared plus x minus 3 over x times x plus 1 squared. And can I factor x squared plus x minus 3? I don't think I can. So that's as far as I can go.